Hi everyone. I'll be presenting on effects of stimulus type, duration and level on the minimum audible angle, and myself Arun and my co-authors are Arshada and Nisha KV from All India Institute of Speech and Hearing. Starting with the significance of minimum audible angle, that is MEAA. According to Mills in 1958, MEAA is defined as the smallest angular separation between two sound sources that a listener can reliably discriminate. And MEIA quantifies our ability to detect small changes in the sound direction, and it is essential for accurate localization in space. And it enables differentiation of sound sources in complex environments, such as locating a speaker in a noisy room. And the lower MEIA values indicate finer spatial resolution, revealing how well the auditory system encodes the spatial cues. And moving on to the need for the study, according to Mills in 1958, spatial discrimination is highly influenced by stimulus characteristics such as frequency, content, and complexity. And by various authors, they all stated that both stimulus duration and intensity modulate localization performance with shorter and softer sounds, resulting in higher MEA thresholds. Despite these known individual effects, their combined influence remains underexplored, and comprehensive investigations into how acoustic and temporal features jointly influence the MEA are limited. And the aim of the study, this study examined the effects of stimulus type, duration, and presentation level on MEA thresholds in normal hearing individuals. Objectives are to compare the MEA threshold in normal hearing young adults across these three stimuli, three durations, and a three presentation level. And the participants on the study design, we recruited 15 normal hearing young adults, and it's a 3 into 3 into 3 within subject factorial design. Factors are stimulus type, duration, and presentation levels. Next is the stimulus and apparatus. All the stimulus were generated via Adobe Audition software, and the specialized version were created via 3D tuning app and presented with calibrated headphones. This is the experimental setup depicting the MATLAB-based 3 alternate 4 choice method used for measuring minimum audible angle thresholds with specialized auditory stimuli. And this is the picture where we can see three stimulus, the 3 alternate 4 choices given, and the participant has to select the correct answer. And this is the video. The appropriate parameter is selected, and the stimulus were selected. The specialized stimuluses were selected as per the parameter. In this, the participant is responding for complex stimuli with 250 millisecond duration for the 45 dB SPL presentation level. And in all the testings, we used 3 alternate 4 choice method with a reference at 0 degree. And we used adaptive 2 down and 1 up staircase tracking procedure. And MEA thresholds were calculated based on the average of last 4 of the 10 reversals. And the real-time feedback was given. If the participant answered correctly, the green tick mark will be given. If the participant answered wrong, the red cross mark will be given. And for statistical analysis, we use normality test, repeated measures ANOVA, and the PAT test. The data were normally distributed, and these are the descriptive statistics for the 27 conditions, starting with mean and standard deviation for white noise, mean and standard deviation for pure tone stimuli, and mean and standard deviation for the complex stimuli. And as I told, data were normally distributed, and in repeated measures ANOVA, we found main effect for the stimulus type and the presentation level, whereas duration had no main effect. And in interaction effects, only stimulus type and presentation level had the main effects. And we did post-hoc pairwise comparison using PAT test, and we know it's a 3 into 3 into 3 factorial design. So we'll be having 27 pairs for stimulus comparison and 27 pairs for presentation levels comparison. Out of the 27 pairs for the stimulus type, we found 13 pairs were significant. And we can see in the graph, and all the 4 graphs, we can see that complex stimuli is significantly having lower MEA mean thresholds. And for same in presentation levels, out of 27 pairs, we found 13 pairs were significant. And we can see in this all 4 graphs that higher presentation level, that is 65 dB SPL, 65 dB SPL, having the significantly lower MAA thresholds. And the interpretation from this study are as follows. First one is spectral complexity enhances spectral cues because spectrally rich stimuli provide more frequency specific information, aiding the auditory system in resolving spatial cues like interaural level and spectral differences. This leads to better sound localization and spatial discrimination. Second interpretation was louder levels strengthen neural encoding because higher stimulus intensity improves neural synchrony and face locking, which enhances the encoding of spatial and temporal auditory information, and this supports more precise spatial resolution in tasks such as MEA. And final interpretation was duration did not significantly affect performance because beyond a minimal duration threshold, increasing stimulus length has limited effect on spatial resolution, and MAA performance remains stable once adequate temporal information is available. And the one-line summary of the study was increased spectral complexity and higher intensity significantly improve auditory spatial resolution in normal hearing listeners. And to conclude, stimulus type and intensity significantly influence the MEAA, and the complex tone and 65 dB SPL offer best spatial resolution with duration had minimal impact. And thank you. And thank you once again for the wonderful opportunity.